So we want to do an example out of this find the inverse with blobs idea. So I want to see if we can find the inverse of f of x is log of the quantity 2e to the x plus 3 all over 8 plus 1. So to start this with blobs, I know it's terrifying, right? This is super complicated, but you just take it one step at a time, right? Okay, so at the beginning, there was an x, right? What did you do to x first?
Yeah.
So we did e to the stuff to it first. Then what's the next thing you do?
Multiply by 2.
Multiply by 2. Okay, then the next thing after that?
You add 3.
Add 3. Okay, then what?
Would you log it next?
Then you need to log it. Then you
Divide by 8.
divide by 8.
And you plus 1x.
And then you plus 1. Okay, so I have now written my function that I started with as a composition of 1, 2, 3, 4, 5, 6 steps, right? So how do I come back, right? So maybe I should do this. This whole path from beginning to end, that business is f, right? So how do I back out of f?
Negative 1.
Okay, so we should
Subtract 1. Multiply by 8.
10 to the stuff.
Yep, so the opposite of logging is 10 to the stuff.
10.
Add 3 is subtract 3. Unmultiply by 2 is
Divide by 2.
divide by 2. And e to the stuff
Wait,
is
Oh.
natural log of the stuff, right?
That's just
Really, actually, maybe I should add that here to my log. All right, so can you guys construct that?
Like make a function.
Yeah, so f inverse of x,
He
right?
wants to math this.
Yeah, I want you to math it. So what do you start with when you're doing a function?
We have to name all of them.
So I don't need to write this as a composition. I'm just trying to calculate the inverse.
Oh.
So I just start with an x, and I leave myself a good, maybe a bit more space,
yeah.
right? I'm going to have to do a lot of stuff for this x.
So you subtract 1?
Yeah.
So first things first, I need to subtract 1.
That whole thing.
And
And then parentheses 8.
Then I need to multiply the whole thing by 8. Then what?
Put all of that in the thing with 10.
yeah.
And all of that's got to go in the exponent of a 10.
And then you got minus 3 from that whole thing.
Then I got to subtract 3 from that whole thing. And my font size is increased, right? Because the stuff I started with that I mistakenly wrote normal size ended up in exponent size.
Kind of like a pyramid, right?
Okay, and then I need
Do you
to,
divide all of it by 2?
then I need to divide all of it by 2. Oh. So then I need a giant natural log of that stuff, right? And that's your f inverse of x.
If you always
Nice.
make that big, you could watch it on your phone.
Yeah.
How did you figure the Reddit order?
The black order or the red?
The bottom? I don't know.
The bottom?
The natural log of 10, 8, x minus 1. Like,
Oh, how did I like do this?
yeah.
Okay, so if my function does that way, right? My unfunction should do this way.
Yeah.
Yeah. And so I just undid the process. So my process over here, right, to figure the black out, was to say, okay, if I plug an x in here,
Oh, okay, so
the
it's
first thing I do is put it in the exponent of an e, then I multiply by 2, then I add 3. And I was just thinking, okay, the first thing I've got to do is subtract 1. So I started with an x, right?
yeah.
Oops.
Need a red one.
I started with an x, and then I went to x minus 1. And then I had to do the multiply by 8 function to all of that stuff. So I got 8 times x minus 1. Then I had to put that stuff in the exponent of a 10, so I got 10 to the 8 times x minus 1.
Okay, that's
Then I subtracted 3 and kind of so forth. Cool?
true.
Questions, things?
What happens if you get something that can't be undone, like the square root function that doesn't like being undone? Would we use i's then?
So if we had a square root, the undoing of a square root might be squaring, right? It's the squaring one that you would have a problem with.
Yeah.
So if you found a squaring here, there isn't an inverse.
Okay.
And actually, if you found a square root in here, there also isn't an inverse in the way we mean an inverse. So in this class, when we say inverse, what we mean is that if I do the red arrow and then the black, I get back to where I started. And also if I do the black and then the red, right, in the other order, I get back to where I started. So I can start on either end and get back to where I started. That's never going to be true if you have a square root and a square in the middle of this thing.
So then that holds true for any even number.
Yeah, any even power is going to wreak havoc with this thing.
All right.
And actually, it still has problems if you move to ILAM.
Okay.
Those problems don't go away. They just get weirder.
No,
ILAM, complex numbers. Yeah. It still has problems. It's still funky. Cool? Other things? This technique of writing down the bubbles doesn't quite always work. There are a couple of kind of functions that you can invert that this technique is not nice for, but I think this is the best way to understand the idea.
So
Other
since
things?
this is already done, kind of like number 3 on the practice test.
All right, so let me add to my previous example of find the inverse. We could write this already as a composition of 6 functions, and we kind of did. Those functions were, what would a labeling be for that first one? Okay, so we're going to call that A because it's the first one probably, right? And so you're going to say, okay, A of x is, and what's that one? E to the x, right? When you do A to an x, right, this first rule, you get E to the x. Okay, what's the next one? Probably B, right? B of x. And what's the rule B do?
X2.
X times 2 is 2x, right? How about the next one?
C of x is x plus 3.
Okay, so C of x is x plus 3. Seems like that makes sense. How about my next one?
C of x is log.
D of x is log of x.
Yeah.
Divide by 8 is
E of x. E of x is x divided by 8.
that hurts. E is a number, right?
Yeah.
It's also apparently a function label here, which is not a good idea, but whatever. So that would be x over 8. My slant's getting heavier and heavier here. And my last function,
I use g since we already have.
yeah, we already used f, so maybe we'll use g. And g of x is
X plus 1.
x plus 1. And then if I wanted to write this as a composition, I'd say, okay, so f of x is
G composed of E composed of D composed of C
G composed with E, composed with D, composed with C, composed with B, composed with A of X. And the reason we write in this kind of funky, backward-seeming way is,
You start with A of x, you work with it.
yeah,
Plug it
that
into the
G,
next one.
right, in our order of operations. We start with the grouping symbols. And so we start on the deepest grouping symbol and then move out. We do A first, then B, then C, then D, then E, then G. Cool? Does that help? There's a kind of a cool thing actually if I went backwards, right? What was F inverse of X in terms of,
Well, they were the opposite operations.
Yeah.
It's not like
Uh-huh.
you can take those operations and put them in a different order, because it'll be
Yeah, they were the opposite operations, which are what?
Oh.
Subtract one.
Oh, it's all.
Jesus.
Right? The opposite of g, right, x plus 1 is subtract 1.
Yep.
So g inverse is subtract 1. What's e inverse?
Divide, no,
Times.
multiply by 8.
Multiply by 8. What's d inverse?
10 to the stuff.
10 to the stuff. So notice I'm just going to do the reverse operations in the reverse order, right? So I'm just going to do A inverse last, then B inverse, then C inverse, then D inverse, right? I'm listing these kind of backwards, the order I'm going to do them in. E inverse and G inverse, all of X. You see
You
that?
have to relabel anything because you just write the inverse and then it's,
Uh-huh.
okay.
Yeah, so this is another way to think, right? When I want to do the opposite thing, if I can write it as a composition, I can just flip the order and do the opposite operation. Cool. That's actually what we've been doing all along. This is kind of the punchline of Algebra 2. When you're solving, you're just making a bunch of inverse functions, right? But the key to solving is you apply the opposite operations in the reverse order.